Hello friends, in this video lecture we are going to discuss the contingency analysis. So let us begin. So friends, in our previous lectures we have discussed related to the power system security, and we have understood that contingency analysis is an important related to the power system security. Okay, so let us discuss how the contingency analysis is done, or how the contingency analysis is carried out in the power system. Okay, so before this contingency analysis we have discussed some ideas related to the contingency analysis. We have discussed how to model the power system for the contingency analysis. As per the requirement, we can model the power system in different ways, taking the help of Newton-Raphson method of the load flow, or we can take the help of the decoupled load flow method, or in some case we can go with the fast decoupled load flow method as well. Okay, again we have discussed during the security analysis that contingency analysis, basically it is done, or the three major functions of the contingency analysis we have discussed. The first one, it was the definition of the contingency, and means in definition what we get, the program which we are using to perform this contingency analysis, what it will do in the first function, it will predict some number of contingencies, okay, which are possible, and it will give those list. Okay, and in second step what the program has to do, it has to select the contingencies which are more severe from that list, okay, which are less severe, or the possibility or the probability of the occurrence of those contingencies, if it is low, then we can neglect them. Okay, so then from the selected contingency we have to go for the evaluation. Okay, this way the contingency analysis process goes on. Okay, so let us see with an example here how actually it is done in practical system. Okay, see, in the past many widespread blackout have occurred in the interconnected power systems. Okay, therefore it is necessary to ensure that power system should be operated most economically, such that power delivered reliably. See, we have discussed in the introduction of the power system security is that the two major functions, or the two important functions that are related to the satisfactory operation of the power system are economics of the power system, and the second one is the security of the power system. Okay, so in order to ensure the satisfactory operation of the power system, what we have to do is that we have to make sure that power system is going to operate most economically, and again the power is going to be delivered reliably. Okay, see, reliable operation, what it means, it implies that there is adequate power generation and the same can be transmitted reliably to the load. Okay, so this is the meaning of the reliable operation. Okay, again, the most of the time the power system, practical power system what we have, are designed with enough redundancy. Okay, so with that what happen, the power system, they are able to withstand the major failure events as well. Okay, here we shall study the possible consequences and remedial actions required by the two main failure event. Okay, so now what we are doing is we are considering only two type of the contingencies. Okay, one is we are considering the contingency of line outage, and the another is what we are considering is the generator unit failure. Okay, so for these two contingencies, how the contingency analysis is done, let us discuss that. Okay, to discuss this problem briefly, we consider the 5-bus system. Okay, the 5-bus system is shown in this figure. This is bus 1, okay, this is bus 2, this is bus 3, bus 4, and this is the bus 5. Okay, here the generators are connected on bus number 1 and bus number 2. Of course the bus number 1 is the slack bus. Okay, and one more generator we have on the bus number 2. Again, the loads are connected at remaining all the buses. Okay, from bus 2, bus 3, bus 4, bus 5, we have the load. Okay, again, on each bus, what is the value of the voltage is indicated here. Okay, on the slack bus, the voltage is 1.06 to the angle 0 degree. On the second bus, the voltage value is given. On the third bus, on the fourth bus, and on the fifth bus, the voltage values are given. Okay, again, apart from the voltage values on each bus, the line flows are also mentioned here. Okay, how the power is flowing from the bus number 1 to 3, it is going in that direction, and again in opposite direction also it is given. For each line, the power flow is indicated here. Okay, again, the power injected or the power delivered by all the buses are also be mentioned here in this diagram, okay, or in this figure. Okay, so here first let us consider that 5 bus system we are taking. The base case load flow result for the example are given in this figure. Okay, we have seen on different buses, we can have the idea what is the value of the voltage at all the buses. We know what is the line flow. Okay, on all the lines. Again, we know what is the power injected or power delivered by the bus, so that we know. So it means that we have performed the load flow here and we have obtained the result. That is what it is shown in this figure. Okay, and show the flow of 24.7 megawatt and 3.6 MVAR on the line from bus 2 to 3. Okay, from bus 2 to 3, you see, from bus 2 to 3, this is it is showing that the flow is 24.7 megawatt and 3.6 MVAR. That is nothing but the reactive power, and the real power is 24.7. Okay, now you see, let us consider one contingency. Let us consider that line outage. Okay, let us assume that at present we are only interested in the megawatt loading of the line. Okay, and let us examine what will happen if line from bus 2 to 4 were to open. Okay, if suppose if this line, that is the line between the bus 2 to 4, okay, this line, okay, if I open this line, or suppose if the line is going to open, if this contingency is going to be there, what will happen, what is the consequence of this? Let us examine that. Okay, so resulting line flow and voltages are shown in the below figure. Okay, so let us see that. Okay, you can clearly see here the line between two bus number 2 to 4 is now missing here. It has been opened now. Okay, so what consequences it will have? You can see earlier on the bus which was connected between the line which is connected between bus 2 to 3, the flow was it was, you see, it was 24.7 plus j 3.6, 24.7 plus j 3.6. Now it is been increased. Okay, from 24.7 megawatt. Now the this line is overloaded now. Okay, earlier it was loaded with 24.7 megawatt. Now it is carrying 37.5 megawatt. Okay, so overloading of the line is happening here. We can easily see that. Okay, again we can see other things as well. Okay, the voltage on the bus 2, you see, it is changed. It was earlier 1.0474 angle minus 2.8 degree. The voltage has changed here. Okay, so how the things will be when there is a line outage, we can analyze here. Okay, and what we have to do over here is that we have to check. Definitely overloading will be there, voltages on buses are changing, line flows of the lines are changing. So just examine, is there anywhere the violations are there? You just check. Okay, violations in the sense the voltage on the bus should not violate its limit, the line carrying the power, it should not violate the maximum carrying capacity. Okay, so that you have to check for this condition. Okay, so that is what given here, what we have to do in case of the contingency analysis. Okay, so here it may be noted that the line 2 to 3 has increased, that we have seen from 24.7 megawatt, now it has been carrying around 37.5 megawatt. Okay, and most of the other lines are also changed. Okay, we can see, you just observe this line, the line between bus 2 to 5, the loading of this line is also changed. Okay, earlier it was 54.8, now it is 63.1, so loading has increased on this line as well. Okay, again, even you can see the bus line connected between bus 1 and 3, loading on that line is also changed. Okay, so loading on all the lines maximally, we can see, is changed now. Okay, the bus voltages are also changing here, so that you have to check for. Okay, so we can see that the voltage loading has changed. Again, the voltage will also change. Okay, particularly at bus 4. Okay, let us see what is the value here. 1.0236 to the angle minus 5.3. It was 1.0236 to the angle minus 5.3. So now it is changed to 1.0068. Okay, so there is almost 2% change in the voltage at the bus number 4 we can experience here. Okay, again, let us consider one more line outage. Okay, let us consider the line between the bus 2 to 5 were to open. Okay, then resulting flows and the voltages will are shown in the next figure. Okay, in that we can see that the maximum change in voltage is happening at bus 5, which is almost 10% less. So let us see that. Okay, now what we are going to do is we are going to open this line. Okay, let us open this line and let's see. See, this line is open now. Okay, so now what is been point we can note here. See, you can note here that loading of the line has changed now. Okay, all the lines are now carrying some other power. Okay, particularly here the notable point is that the voltage at the bus 5 is dropped by 10%. Okay, let's see what was the value earlier. The earlier value was 1.0179 to the angle minus 6.2. Okay, it was earlier 1.0179 to the angle minus 6.2. Now it is changed to 0.8994. So there is a 10% drop in the voltage on the bus number 5, which is the maximum change. So this way we can get to know what is the variation in the voltages on the buses, what is the variation in the line flow. Okay, so we will get to know from this, is there anywhere the violations are there. Violations in the sense the voltage should not get more than the prescribed value, or it should not be less than the prescribed value, it should be within that prescribed range. Again, the loading on the line should not exceed its thermal and static stability limit. Okay, if it exceeds, then there is a possibility of the line failure will be there. So that we have to analyze. Okay, see, actually this line is not open. The line between 2 to 5 bus is not open, but what we are doing is we are considering that in coming time the line between 2 to 5 may get open. Okay, so if it gets open, what will be the scenario we are analyzing here, and based on this analysis we can decide some action plan. And if suppose in future, if there is a failure, if such failure comes that the line between 2 to 5 if it opens, then we are having the action plan for that. Okay, so this way the contingency analysis will help us to reduce the emergency condition or to alleviate the emergency condition. Okay, sometime we can decide the pre-contingency things. Okay, like we can do the rescheduling. Okay, let us say if I come to know that the line between 2 to 5 is now going to break. Okay, if it is now going to open, the reasons may be, number of reasons might be there. Suppose if I get to know, what I can do is if I want to do the pre-contingency precaution, so I can shift the load of the line between 2 to 5 to other lines. Okay, in such a way that the voltages and the line flow should not violate their limits. That way we can do. If suppose if it opens, let's see, analyze the things and decide the action plan. Okay, again this is related to the things where we are having the line outage. Okay, one more thing is possible, that the generator failure will be there. Okay, so what happen when the generator failure will be there? Okay, now let us consider, for the 5 bus system what we have considered, we are considering the 2 generators are there. Okay, consider the generator which is connected at bus 2 is now going to fail. So what will happen? The load of this generator will be taken by the generator connected at the slack bus. It is because that in the system we are having only 2 generator, and out of that one generator is failing. So all the load will be shifted to the generator which is connected at this bus. Okay, if suppose if I have one more generator connected here. Okay, let's say this is the G3. Okay, this is G1 and this is G2. Okay, if there is a failure of the G2, then in that case the load of this G2 will be shared between G1 and G3, between generator 1 and generator 3. But as we don't have generator 3 or generator at any of the bus except slack bus, so all the load of that bus will be shifted to generator which is connected at the slack bus. So how the things will be look like, that we can analyze here. See, the generator at the bus 2 is now failed, so all the loads from the generator number 2 is now shifted to the generator which is connected at the slack bus. Okay, accordingly we can check the loading. See, if you check here, the loading on this line between bus 1 and 3 is changed. Earlier in the base case, okay, that is the pre-contingency case, it was just 88.9. okay, now you can see here it is almost 123.8. okay, so this way we can do the analysis and we can decide the action plan. Okay, so as said, the generator 2, if it fail, the load will be picked up by generator number 1. Okay, see, the difference in line flow in the bus voltage shows lost generator is shared by the remaining unit is quite significant. Okay, again it is important to know that which line or unit outage will render line flow and voltage to cross the limit. Okay, after doing that, let's say from the contingency definition and selection we get that first, contingency is the failure of the line between bus 2 to 4, second between bus 2 to 5, then generator failure. Okay, then what we can do is we can check the severity, which is more severe, which line failure or which generator failure is more severe, and accordingly we have now got the list. And now let us evaluate that. Evaluation we can do this way, as shown in the above figures. Okay, now from this we will come to know which contingency is causing the voltage or the line flow to cross the limit. Okay, and to find the effect of outage, contingency analysis technique is employed. Okay, so to identify which contingency is causing the line flow to cross the limit or the voltage to cross the limit, we can do that. We can get that things with the help of this contingency analysis. Okay, see, contingency analysis model single failure event, that is the one line outage or one unit outage, or multiple equipment failure. Okay, that is the failure of multiple unit or line or combination of the line, or the combination of line and generator as well. Okay, one after another unit, all the credible outages are considered. Okay, one after another, what are the list of the outages will be given, we will analyze all those things. Okay, or we will consider all of them. Okay, for each outage all the line and voltages in the network are checked against the respective limit. Okay, for each outage we saw that the voltage at all the buses and the line flows have changed, so we have to check against the respective limit. Okay, now the algorithm for the contingency analysis is given in the below figure that we will discuss now. Okay, one of the important problem is the selection of all credible outages. Okay, that is very important, because the contingency definition will give us the very big list. Okay, it will give the prediction related to the failure, a big list will be there. Now it is important to select the credible outages only. Okay, because in power system number of failures are possible. Okay, so we cannot do this contingency analysis for all the failures. So the selection of the credible outages, or the selection of the credible credible failures in the sense, the failures which will make the voltage or the line flow to cross the limit, that failure or that outages we have to select. Okay, so that is very important part here. Okay, again, the execution time to analyze the several thousand outages is typically 1 minute based on the computer and analytical technology as of it was the situation in the year 2000. Okay, so the computers were used to take only less than a minute to analyze this thing. Okay, still we want more fast analysis of this. Okay, again, we can use the different models according to the requirement. So let us discuss the flow chart or the algorithm for this. The flow chart says first start, okay, then initialize the system model. So as per the requirement you can go with the system modeling. Okay, put or let n is equal to 1. Okay, that is the unit number, n indicating the unit number. Simulate an nth unit outage. Consider the nth unit out of, let's say we are having n unit, any unit you consider, and simulate for the outage of that unit. Okay, check line flow limit violation. If there is a line flow limit violations is there, if it is yes, give the alarm signal. If it is no, then go for and check this condition. Any bus voltage crosses the limit. Okay, check the voltages at the buses. If is there any violation in the limit, then if it is yes, give the alarm. Okay, if it is no, we have to check for outage of another unit. Okay, just check, do we have consider all the units? If yes, then we can go down. If no, repeat this loop. Okay, go for the next unit. Okay, this way we can consider all the units. Okay, one by one we will consider the outage of all the units, and we will see the outage of which unit will cause the line flow limit violation or voltage violation, and accordingly we can give the alarm signal. Okay, this is related to the generator unit outage. Okay, we may have one more type of the contingency, that is the line outage. Okay, let's say this I is indicating line. Okay, once we have considered all the units, if it is yes, now let us simulate for the lines. Okay, let I is equal to 1, that is the first line consider. Simulate the ith line outage. Okay, here I must write line outage. Okay, so if the ith line outage, just check any line flow limit violation. If it is there, if it is yes, give the alarm signal. If it is no, now check the voltage at all the buses. Okay, if the violation is there, if it is yes, give the alarm. If it is no, go for considering line. Okay, just see whether all the lines are considered here. Okay, if all the lines are considered, then we can end the program. If not, repeat the same thing for next line. This way we can cover all the lines in the power system. Okay, so this way the contingency analysis process is carried out in case of the power system. Okay, thank you very much.